Hello student, welcome to chemistry class with Olalekan. And in this lesson today, we are going to be looking at solution and introductory part. This video is brought to you by Igota Virtual Learning. In today's class, we are going to look at the definition of solution and what solution is made up of. We are going to look at the types of solution based on the amount of solute present, based on properties, based on type of solvent used, based on the state of matter, and based on dissolution of solute in solvent. We're also going to look at the properties of solution. Now let's look at what a solution is. A solution is a homogeneous mixture of two or more components, usually a solute and a solvent, in which the particle size is smaller than 1 meter or 1 nm. When we say homogeneous, that means that the mixture is the same all through, they are of the same kind. A common example of this is when you dissolve sugar in water. You observe that the sugar it forms a sugar solution which is the same all through. And the same thing when you have salt, you have a salt solution. When you have salt being dissolved in water, you have a salt solution that is the same all through. You have another example is soda water. In a typical solution, all the components appear in a single phase. You can try this at home. Put some amount of salt in water, stir it together. You observe that what you see is just water, but when you taste it, you have the water being salty. That means a salty water. You only see the liquid. That means they are the same all through. So the particle is homogeneous. Like we have said, they are evenly distributed. That is why you see a whole bottle of soft drink. They have the same taste all through. It's not that when you take a particular bottle of soft drink, at the beginning is sweet and at the end is sour. No, it is sweet all through because it is a solution, and of course, a solution is known to be homogeneous or the same all through. Now, a solution is usually made up of two components, which is the solute and the solvent. The solute and the solvent. An example, the solute is usually a solid, while the solvent is usually a liquid, but it can be more. You can have gaseous solute and solvent and the likes. But usually, the solute is the one that is being dissolved, while the solvent is the one that is dissolving. And of course, when a solute is combined with a solvent, it produces a solution. Solute plus solvent will give you a solution. So, like we have said, the solution is a combination of an homogeneous mixture of a solute and a solvent. Now, what happens when a solute dissolves? Um, these are key things you need to understand. Number one is that there are attractive forces between the solid particles holding them together. In a typical solute, you have attractive forces, whether cohesive or adhesive, or even some other forces that holds the particles of a solute together. There are also attractive forces that is holding the solvent. So there are forces acting on the solute and there are forces acting on the solvent. When you now mix the solute with the solvent, there are attractive forces between the solute particles and the solvent particles. So if the attractions between the solute and the solvent are strong enough, then the solute will dissolve. If the attractions between the solute and the solvent are not strong enough, the solute will not dissolve, or will dissolve partially. And that is why you can have complete dissolution, you can have partial dissolution, and you can have no dissolution at all. That's why you can have soluble, slightly soluble, and insoluble substances, as the case may be. So if you check the diagram here, you observe that you have a solute-solvent interaction. Uh, that's number one. In a typical dissolution scenario, you have a solute-solute interaction. Like we have said, that there is a force of attraction between the particles of the solute. Then that you are going to have a solvent-solvent interaction. There is a force of attraction between the solvent particles or molecules. Then when you now mix both the solvent and the solute together, there will be a solvent-solute interaction. If the force is strong enough, then the solute dissolves. Now, let's take an example of table salt dissolving in water. This is an example of dissolution of an ionic compound. Sodium salt is an ionic compound because it has a sodium chloride, and sodium is having the positive while the chlorine is having negative, so it's ionic. Now each ion is attracted to the surrounding water molecule and pulled off and away from the crystal lattice. Where when they enter into the solution, the ions is surrounded by water molecules, insulating it from other ions. The result is a solution with free moving charged particles able to conduct electricity. Now, what do we mean by this? When you dissolve salt in water, for instance, you observe that they form ions. We call it ionization. As a salt, the atoms of each of these submolecules, which is sodium and chlorine, they have zero electric charge. But by dissolving them in water, they move from compound or atom or ion to atom or a compound to ions. This process is called ionization. Then by dissolving them in water, you begin to have Na plus and Ca minus. Now the ion, each of the ion that is being produced by dissolving them in water, they are surrounded by water molecules themselves, and then they get to pull away from the crystal lattice structure of that sodium chloride. Now, by the time they enter the solution, they are surrounded by water. Then, of course, each of them are insulated from one another by this water molecule. So, therefore, they are able to move about, and that is why a salt water can conduct electricity because it has free mobile ions. Because it has free mobile ions, which are the sodium ion and the chlorine ion, respectively, inside it. So, this is the chemistry of dissolution of salt, especially ionic compounds in water. Now let's look at salt versus sugar dissolved in water. Now you observe that salt dissolution in water is ionic compound being dissociated into ions when they dissolve, because salt is ionic. By the time you get to sugar solution, sugar is molecular because it contains of covalent compounds. Salt is ionic because it contains ionic compounds. So, therefore, because it is a molecular compound, they do not dissociate when they dissolve. For salt, because it is ionic compound, they dissociate into ions. Hence, they can conduct electricity. Sugar solution or sugar, when it is dissolved in water, because sugar is a molecular compound, it's a covalent compound, do not dissociate into ions. Hence, they cannot conduct electricity. This knowledge is very key. So, molecular compounds do not dissociate when they dissolve in water. Hence, they cannot conduct electricity. Ionic compound dissociate into ions. Hence, they can conduct electricity. Now, let's look at different types of solution based on the amount of solute that is present. You can have a concentrated solution or a dilute solution based on the amount of solute that is present. The difference between concentrated solution and a dilute solution is the amount of solute that is dissolved in the solvent. Hence, a concentrated solution is a solution that has a relatively large amount of solute that is dissolved in the solvent. And then we now say this one is concentrated. We use concentrated. You'll have heard of that before. The concentration of a concentrated solution is at or is approaching the solubility of the solute. For a dilute solution, it has a small amount of dissolved solute in it. The concentration of the dilute solution is significant is lower than the solubility of the solute. Now, what do we mean by this? Let's take an example. Let's say we dissolve copper 2 of 6 inside water. You can try this in your lab, and when you have, let's say you have small amount of water, you want to measure 2 grams of CuSO4 inside water. You observe that the color of the blue solution is deeper when you now have 2 grams being dissolved in, let's say, 500 centimeter cube of water. When the amount of solvent is smaller than that of the solute, you are going to have a concentrated solution. So in a typical concentrated solution, solute is greater than the solvent. The amount of solute is greater than the solvent. In a dilute solution, the amount of solvent is greater than the solute. So in a concentrated solution, the solute is usually more, and then of course it forms more color. You can see here that the dark solution appears. You have a deep blue solution. Why? Because there are a lot of solute in a small amount of solvent, and that's why you can hear the word concentrated acid. By the time you hear concentrated acid, what it means is that the amount of the acid is more than the amount of solvent that is there. And the amount of the acid is more than the amount of solvent. But by the time you add more water to the concentrated acid, it becomes dilute because the amount of solvent has now increased than the amount of the solute. Now, the word concentrated and dilute, they are used to compare solution. But of course, also take note that concentration can be expressed more quantitatively using measurement unit. You can change the concentration of a solution by adding more solute to make it concentrated. And then, of course, if you want to make it dilute, you add more solvent. If you want to make it concentrated, you add more solute. If you want to make it dilute, you add more solvent. And an example of concentrated solution includes acids used for cleaning bricks. You have the brine solution, you have the orange juice, and dark color tea. An example of a dilute solution includes detergent, salt solution, and light color tea. Okay, let's look at another type of solution. So we are based on properties. Generally, we can have acidic, basic, and neutral solution. An acidic solution is a solution that has a pH less than 7. In a typical pH scale, you have 0 to 6, 7, and 8 to 14. Between 0 to 6, you have the acidic. And then when it comes to 7, you have neutral. From 8 to 14, you have basic. So any solution that has a pH that is less than 7 is acidic. Any solution that has a pH greater than 7 is basic. And any solution that has a pH of 7 is neutral. Let's look at some of the examples of acidic and basic solution. An example of an acidic solution is acid rain. Generally, acid rain is formed as a result of gases being formed in the atmosphere. They dissolve in water vapor. Examples of these gases are the NO2, the SO2, the H2S, etc. Where they are usually formed, even the CO2 and CO, they are usually formed due to human activities, and then when they go to the atmosphere, they get dissolved in the water vapor, and they come back as they come back with the rain, and that's why they tell you that the first 2-3 times when the rain starts in a year is usually much more acidic in nature, and of course the harm forest and aquatic life. An example of a basic solution is what is known as the antacid. They are also called the laxatives. An example is sodium bicarbonate, magnesium hydroxide, or calcium carbonate. They usually react with stomach acid to either lower the acidity or raise the pH. Inside your stomach, we have what is called the stomach acid, which is HCl. When you eat food containing high level of acid, you notice that you get stomach ache. Or of course, they ask you to go and get an example is an Andrew liver salt, which is an antacid. They also call them laxative. The work is that it is basic in nature. That solution is basic in nature. When you take it, it neutralizes the acid inside of you and return it back to the normal pH it's supposed to be. So that's an example. Another example of a basic solution is sodium bicarbonate. Usually use sodium bicarbonate during cooking. They use it to cook some of the okra soup, etc. So this is it also used in baking as well. Then another example of basic solution is an ammonia solution, and then another example is also bleach. An example is hypochloric acid, normally called hypo. So these are examples of acidic and basic solution. Now, let's check again for acidic, basic, and neutral solution. Their pH range for acidic is below 7, and then an example is battery acid, your stomach acid, and orange juice. For the neutral one, they have a pH of 7, and then an example is distilled water, and even your blood has your blood solution has a pH of 7. If it's more than that, the person can die. For the basic is above 7. An example is for the neutral, you have distilled water. They do not contain usually ions. They are neither acidic nor basic. Then for basic, your blood is slightly basic. You have a pH of above 7. Then you have an example is the bleach, the seawater, and the blood. Now, having said that, you observe that the hydrogen ion to hydroxide ion for acidic is H plus is greater than OH minus. In neutral, H plus is equal to OH minus. In basic, H plus is less than OH minus. Now, let's look at another type of solution. You have the aqueous and the non-aqueous solution. Sometimes the non-aqueous can also be called the chemical solution. The aqueous and non-aqueous solution, the difference between them is the type of solvent that is used. An aqueous solution is a solution in which the solvent used is water. When the solvent used is water, it is an aqueous solution. And of course, note that water is a polar solvent. It has two poles, H plus and OH minus. Of course, hence it is a form of liquid solution. So examples of aqueous solution includes dissolution of salt in water to form salt solution, sugar solution, copper sulfate solution. That's CuSO4 in water. For non-aqueous solution, when you have solvent as any other thing rather than water, you have a non-aqueous solution. When the solvent is water, it is aqueous. When the solvent is not water, it is non-aqueous solution. And the solvent here under non-aqueous solution can be polar or non-polar. For instance, the solvent can be ethanol, and ethanol is polar. So, and the solvent can be ether, which is non-polar or organic in nature. So, therefore, a non-aqueous solution can be solid, can be liquid, or can be gaseous solution. An example of non-aqueous solution includes the tincture of iodine, that's iodine reacting with iodine plus alcohol. Then other ones include iodine in CCl4, sulfur in CS2, and phosphorus in an ethyl alcohol. These are examples of non-aqueous solution. You can see an example of non-aqueous and aqueous here, as you have seen here. Now let's look at another type of solution. Another type of solution we have is solid, liquid, and gaseous solution. This is based on state of matter. For solid solution, both the solute and the solvent are in the solid state. Generally, alloys are found here. An alloy is a combination of two or more metals being combined together. So the solute and the solvent here are in the solid state. For liquid solution, you can have a solid, a liquid, or a gas being mixed with in a liquid state. That means the solvent can be a liquid, and then it can be added to the solute can now be solid, liquid, or gas, as the case may be. An example is alcoholic beverages. All the small stout and everything that you have, for instance, most of them are either gases in liquid or liquid in liquid, as the case may be. These are liquid solution. And another one is gaseous solution, where you have the solute and the solvent being gases. An example of that is here. Here is a mixture of gases. You have some of the dissolved gases inside it, etc. Okay, so based on state of matter, you can have solid, liquid, and gaseous solutions. In solid solution, for instance, solute and solvent are in solid state, like we have said. In liquid solution, solid, liquid, or gas is mixed in a liquid state, and in gaseous solution, they are usually a homogeneous mixture of gases like air. Then to break it down further, you can now begin to have gas solid. You can have the solute can be gas, while the solvent is liquid. They are usually called foam. When the solute is gas and the solvent they are called foam. An example is a whipped cream. When the solute and solvent are both liquid, they are called emulsion. When the solute is liquid and the solvent is solid, they are called gel. When both of them are when both solute and solvent are solid, they are called solid sol. And when the solute is solid and the solvent is gas, they are called solid aerosols. So this as an example is smoke. So you can study this table again and get more information from there. Now another set or another type of solution can be based on the dissolution of the solute in a solvent. The dissolution of the solute in a solvent. So in this category, we have saturated, supersaturated, and unsaturated solution. And like I've said, it is based on how the solute dissolve in the solvent. A saturated solution is one that contains a large amount of solute at a temperature where it will be reduced. As a result, will crystallize quickly. In a saturated solution, the solution contains as much solute as it can contain at that temperature. It contains as much solute. By adding more solute, it becomes undissolved. Anytime you add more solute, you have an undissolved solution. For an unsaturated, for a saturated solution, like we have said, the solvent is not capable of dissolving any more solute. In a saturated solution, the solvent is not capable of dissolving any more solute. If you add more solute to it, it becomes supersaturated. It becomes supersaturated. By adding any more solute to a saturated solution, it becomes supersaturated. That means it contains large amount of solute. In a typical saturated solution, the solute and the solvent are equal and are balanced, and then you have some deposit of the solute at the base of the solution. In unsaturated solution, the solute, the solvent is capable of dissolving more. Why? Because the solvent is usually more than the solute. So by adding more solute to an unsaturated solution, you are tending towards a saturated solution. It can dissolve more solute. By the time you get to supersaturated, that means you have added more solute to a saturated solution and it contains excess solute, such that at that temperature, the solute will start to crystallize out quickly. Now, an example of saturated and unsaturated solution is what you've seen here. In a saturated solution, like I've said, you have the water and the sugar. They settle down a bit. That it contains the solvent cannot dissolve more of the solute. Any attempt to add more solute to it, it turns to supersaturated. That means you have excess solute. In a non-saturated, the solute is not enough. So by adding more solute to it, you are tending towards saturated. For a supersaturated solution, it has more or excess solute, such that at that temperature, you begin to have the solute being crystallized out. Now, and this is an example of saturated. So in unsaturated, more solute. In saturated, no more solute dissolves. In unsaturated, more solute can be dissolved. In unsaturated, more solute can be dissolved. In saturated, no more solute can be dissolved. In supersaturated, it becomes unstable because you have excess solute and then they begin to crystallize out. And you see the arrow showing increasing concentration of the solute. At unsaturated, the concentration is very low. As saturated, it has a good number. It is well concentrated, but in supersaturated is much more concentrated, as the case may be. So, the third part of our lesson today focuses on the properties of solution. What are the key properties of solution? Number one, a solution is homogeneous mixture. Number two is that its particles are fine, they are very small, they are microscopic in nature, and they are not visible to the naked eye. You usually use a microscope to check to look at it. Number three is that particles of a solution do not scatter light. That the scattering of light is called the Tyndall effect. Only colloids usually scatter light. Solutions are too homogeneous, and of course, they cannot scatter light, so they do not obey the Tyndall effect. Only colloids does that. And then number four is that the solute in a solution remains uniformly distributed throughout the solution and will not saturate through time. And then the solute can be separated. Usually, they can be separated from the solvent using physical method. For instance, you can separate the solute from solvent in a salt solution by evaporating the solution, such that the solvent evaporates or goes away, leaving the solute behind. So, using most of the separation techniques, you can separate the solutions. Then, for a solution has variable composition, and then the dissolved solute is molecular or ionic in size. And then, of course, note that another thing is that a solution can be colored or colorless. It can have color. For instance, when you dissolve CuSO4 in water, you have a blue color. And then it can be colorless, like dissolving salt in water. However, whether colored or colorless, they are generally transparent. You can see through them. They are generally transparent. So these are the properties of solution. These are the properties of solution. So let's take a look at one question from WAEC. WAEC 2020. You have to differentiate between saturated and unsaturated solution. And number two, you have to state two ways by which a saturated solution would be made to dissolve more solute. Because you said it cannot dissolve more solute. The solvent cannot dissolve more solute at that temperature. So how can you make a saturated solution to dissolve more solute? To take 1 minute to answer this question. Take 1 minute to answer this question. If you have answered this question very well, a saturated solution can dissolve solute at that temperature, while an unsaturated solution can dissolve solute at that temperature. A saturated solution cannot dissolve solute at that temperature. For an unsaturated solution, it does not contain undissolved solute, but a saturated solution will contain undissolved solute at that temperature. And then to make a saturated solution to dissolve non-solute, number one, you increase the temperature of the solute. By increasing the temperature of this solution, you increase the solubility, because solubility is temperature dependent. When you increase the temperature of a solution, it becomes more soluble. It increases the solubility. Therefore, it will allow more solute to be dissolved. Another way is to increase the volume of the solvent by adding more solvent. When you add more solvent to a saturated solution, it becomes unsaturated. And of course, we know that unsaturated can dissolve more solute at that temperature. So this is how you make a saturated solution to be able to dissolve more solute. So far, we have looked at what a solution is and what are the components of a solution, the solute and the solvent. We have also looked at the types of solution in 5 different categories. Of course, we have also looked at the properties of solutions. And of course, we have answered one question from from WAEC. In the next class, we are going to be discussing more advanced about solution. Before then, continue to learn chemistry and bye for now.